In this video, we are going to evaluate the integral of secant to the fourth of 2x dx. So first, it's not obvious what our substitution will need to be, and we have secant to the fourth, which we're not sure what we can do with, but we can break this up into secant squared times secant squared, and then maybe use some of our trig identities. So first, let's rewrite the integral as the integral of secant squared of 2x times secant squared of 2x dx. So one of our trig identities tells us that secant squared of x equals tan squared of x plus 1. So let's perform this substitution. So for the first secant squared, we'll replace that with our trig identity. 1 plus tan squared of 2x times secant squared of 2x dx. Then we can distribute the secant squared to the 1 plus tan squared and get secant squared of 2x plus tan squared of 2x times secant squared of 2x dx. Now we can break this up into two different integrals. So we can break this up into the integral of secant squared of 2x dx plus the integral of tan squared of 2x times secant squared of 2x dx. Now to evaluate these two integrals, we're going to need to use different substitutions. So let's first consider the first integral, secant squared of 2x dx. So for this integral, I'm going to let u equal 2x. So then du is 2 dx. So in particular, dx is equal to du over 2. So now, putting this aside, I can rewrite this integral. It's the integral of secant squared of u, and then dx is just du over 2. So I can factor out that 1/2. So I have 1/2 the integral secant squared of u du. Now if we remember, we know how to take the integral of secant squared. The integral of secant squared is just tan. So this is tan of u. And of course we have our plus c since we're evaluating this integral. And now we have to put our u back in. So this becomes tan of 2x all over 2 plus c. But now we have our second integral to evaluate. So for this one, we'll let u equal tan of 2x. And so du, in this case, is secant squared of 2x times the inside of the function, which is 2x, so that's just 2, and then dx. So dx is just du divided by 2 secant squared 2x. So now I can go back to my integral and do some of the substitution. So tan squared of 2x becomes u squared, and then I don't know what to do with secant yet, so I'm just going to write that out, secant squared of 2x. And then dx is du over 2 secant squared of 2x. That works out nicely, so now my secant squared in the numerator and denominator cancel out, and so this simplifies to be u squared times du divided by 2. So I can factor out the 1/2 and rewrite this as 1/2 times the integral of u squared du, which we can evaluate. The integral of u squared is u cubed over 3. And so now we want to plug in u again. So remember, u was tan of 2x. So this is 1/2 times tan cubed 2x over 3. And so we still have this tan of 2x over 2 plus c. We also have a plus c here from evaluating our integral. So putting all this together, we get tan of 2x over 2 plus 1/2 times tan cubed of 2x over 3. So that'll be tan cubed of 2x over 6 and plus some constant c. So this is our final answer.